Good afternoon, everyone. Welcome to this ASA Abloy Academy virtual training session titled Exit Devices, What is Code Compliant? This session should last about 40 to 45 minutes. My name is Tom Seidel. I will be your lead instructor for today. During the session, your line will be muted. However, you can use the Q&A icon on your screen to submit questions as we go along. I will try to address those questions in real time, but we will also have time at the end to answer any questions that come up. The session is being recorded and should be available within 24 hours or so on the Academy website. Also, within 24 hours, you will receive an email from Zoom, which is your proof of attendance if you happen to be saving these short trainings for continuing education points for our partners such as DHI or ALOA. We do not issue certificates of completion for these short trainings, however. We also have about 50 online courses that we invite you to partake at your leisure. To get started, all you need to do is create an ASA Abloy account if you don't have one in the Academy, and you can begin learning at your own pace. Let's go ahead and get things started. When we're talking about exit devices, talking about egress requirements, before we dive into exit devices and egress products, let's talk about why they're used. Over the years, there have been several tragedies, things that have happened that have caused loss of life, deaths, injuries, all due to improper hardware. One issue in particular, in December of 1903 in Chicago, Illinois, there was a fire at the Iroquois Theater. And that theater fire caused about 600 deaths, 250 people plus injured. And the problem with that building was the newest, the latest, the greatest. However, there were no codes in place that provided for survivability of the occupants. The building did not have enough exits. Some of them were hidden behind curtains, and most of them were locked. The theater was overcrowded with over 2,000 people in attendance of a building that was designed for much less occupancy. So things like that. There are a handful of others that we sometimes will talk about, but tragedies like those lead to requirements in building, what we call building codes or standards. And the codes are designed to make the buildings safe. Codes are also designed to make the occupants safe. So some of these codes talks about exit requirements, the quantity of emergency exits, the direction that the doors have to swing, how many doors there have to be, what are the fire ratings. Talking about the codes and references that relate most to our industry, we would be talking about the NFPA and NFPA 101. Those are standards. NFPA 80 is the standard for fire doors and openings in a building. And what that does is talks about where fire doors need to be located in a building, which allows that building to be broken into fire zones to improve the survivability of people in the building, as well as the building staying intact. NFPA 101. NFPA 101 is life safety code. Now, both of these codes are adopted into building standards. Both of these NFPA 80, National Fire Protection Association 80, and National Fire Protection Association 101 are standards that get adopted into the codes. Now, International Building Code has been the law of the land for several years. And when we look at the adoption of these standards into codes, IBC Chapter 10 talks about life safety. And a lot of the things in IBC Chapter 10 are very, very similar to what NFPA 101 life safety code. There are a few different things between the two. NFPA 101 is used in government and healthcare projects. And IBC Chapter 10 covers most other types of projects. And the basic information for life safety that we're going to talk about is generally the doors must swing in the direction of egress when they're serving an occupant load of 50 or more people. IBC tells us also that a room with 50 or more occupants must also have an exit device. The doors must have an obvious method of operation. The device must be mounted between 34 and 48 inches above finished floor, and the actuating portion of the device must extend at least half the width of the door. So speaking of codes and standards, every area in the US has its own local codes. A standard, as we talked about, is a set of criteria by which everything else is measured or compared. And then the code takes those standards and puts it into law. They ratify it into their local building codes as whole or in part. So you can see sometimes local jurisdictions will have something different than what is written in NFPA 80 or NFPA 101. Standard itself is not enforceable unless it's referenced by a code. The code will tell you whether or not something is required. The standard tells you what it is. The code, like I said, will sometimes grant exceptions to standards based on the occupancy type or the occupant load. In other words, how the building is used and by how many people. For example, NFPA 80 tells us all fire doors shall be self or automatic closing. However, in a healthcare I2 occupancy, closers are not required on fire-rated patient room doors. So again, you have to know what local codes have adopted. And the best location to find that information, what is approved in your area, is the website iccsafe.org. That will allow you to search by state, even down to by city. Certain large cities have their own code. California has more restrictive building codes than, say, Utah. Miami-Dade in Florida has much more stricter codes than you might see in Virginia or West Virginia. So by going through that site, it will tell you exactly what the code documents they refer to, which version of IBC, which will then tell you which versions of the standards they had used. And any deviations from that will also be listed in their local codes. So when we're talking about egress, means of egress, in order to select code compliant doors and hardware for a project, we have to think of what constitutes a means of egress. There's exit access, the exit, and exit discharge. Those are three different distinct parts of your means of egress. When they're kept clear and unobstructed, they provide the path of egress that can be both what they call horizontal and vertical to lead occupants of the building to safety. Let's take a look at each one. Exit access. If you see the chart on the right, the grayed area, that is exit access, portion of the means of egress that leads from an occupied portion of a building or structure to an exit. So per that, the entire floor plan there is exit access. Each one of these rooms has a way out. The exit, that is the portion of the means of egress between the exit access and the exit discharge. So we see the exits here are more than just exterior doors at the level of discharge. Vertical exits to the stairs, horizontal exits like cross corridor doors, doors in the middle of a large building that breaks it into fire zones. They're going to be required in certain applications. They're also going to need to be fire rated based on the height and the size of the building, as well as the travel distance. There is a table in IBC, we're going to reference IBC 2015, which is a current one. There is an IBC 2021, but it hasn't been adopted by most jurisdictions yet. 2015 is the most common. So table 716.5 in IBC 2015 tells you the ratings and the exits are what the ratings on the exits are required. And then your exit discharge is a portion of the means of egress between the termination of an exit and the public way. So your final terminations, your final doors out of the building. They're usually at the bottom level of the building and can be found, in whichever area that the people need to be removed from the building. Looking at horizontal exits. Horizontal exits consist of fire barriers and fire-rated door assemblies. They're intended to compartmentalize the building, as we had discussed. Once an occupant passed through a horizontal exit, they're safe from the fire and smoke from the area of origin. They can continue on that path of egress to reach a vertical exit, or they can use a horizontal exit as an area of refuge as they await rescue. Sometimes in buildings with stairwells, you will see that area of refuge that is meant for people who may not be able to easily traverse the stairs. They're in a safe area that people can come and then help them. So the fire resistance rating of the fire barrier and the fire protection rating of the door opening assemblies will vary depending on the height of the building, how many floors, and the type of use for the building. So some of the things to think about. Okay, the authorities having jurisdiction talks about the risk to the occupants of the building. And they calculate things on several different factors, but in our world, important things are the occupant load and the occupancy type. Occupant load is how many people could be in that building. The occupancy type is how's the building used. And requirements will change based on occupancy type as well as occupant load. Occupant load is usually dependent on the type of building that we're using. So occupant load is calculated on a square footage per area and occupancy type. Unless otherwise permitted in code, the minimum number of exits or access to exits per story is 2 for an occupant load of up to 500 people. Occupant load is calculated based on the square footage of the area as well as the occupancy type. We'll show you how to calculate occupant loads and egress in a different online course when you're ready. So the chart here shows you occupant load per story. Up to 500 people would be 2 exits. Up to 1,000 people, 3 exits. More than 1,000 people per level would require 4 exits per story. So looking at the occupancy and classification. The occupancy is how the building is used. Sometimes there can be multiple occupancies within a building. And you have to know which one of these occupancies is the more stringent because that's the one that will be used. So selecting appropriate hardware begins with an understanding of the occupancy types and how they differ. There are 8 different types of occupancies, and then they're broken into subgroups. Assembly, or A type groups. Business, or B type groups. Educational, or E. High hazard, H. Institutional, I. Mercantile, M. Residential, R. Each one of these kind of is self-explanatory, but let's go through and talk about each one a little bit. When we talk about assembly occupancies, Group A includes any use of a building, structure, or portion for the gathering of persons for purposes such as civic, social, religious, recreation, food or drink, as well as awaiting transportation. The benchmark for being an assembly occupancy is 50 or more people. Assembly occupancies are among the highest risk groups in the code. When you have a lot of people concentrated in an area, in emergencies, panic ensues. That's why this is one of the higher risk groups and has special requirements. Group E, educational. That occupancy includes a building or structure or a portion thereof used by 6 or more persons at any one time for educational purposes through 12th grade. Educational occupancies within Group A are assembly and high hazard as the highest risk groups, and therefore will have more restrictive hardware. So in that educational area, as we had talked, a school could have an auditorium. That auditorium has more than 50, then the auditorium would be part of the assembly, and the requirements for an assembly would take precedence over the educational requirements. High hazard. High hazard would be anything involved in manufacturing, processing, generation, or storage of materials that can constitute a physical or health hazard. There are specific requirements for high hazard. Mixed use. Most commercial buildings will have more than one occupancy type. They're called multiple occupancies. And again, each portion of that building will be classified per what type of occupancy that section of the building is. And again, the more restrictive portion is the one that will be applicable. When we're talking about mixed uses, we talk about separated and non-separated. Like a college classroom building, which would actually be in Group B, which is business. College classrooms are business. But in a large room that had a lecture hall and say 400 fixed seats would then be Group A for that lecture hall area. It will have the stricter requirements, the requirements based on Group A, which are more restrictive. So when you're having those mixed occupancies, the more stringent of the codes are the ones that will be adhered to. Red flag areas within other occupancies that could be Group A assembly if they're large enough to hold 50 or more people. Some of the more common ones, if you have buildings that are separated with movable partitions, so you have smaller areas but can be opened into a larger group. So that's broken into what they're calling unconcentrated areas or concentrated areas. So the multi-purpose rooms, meeting rooms, ballrooms, banquet rooms would use a 7 net square foot per person. So in an unconcentrated area, conference rooms, lounges, balconies, rooftop patios, dining, swimming pool deck areas, that's 15 net square foot per person. So those calculations would change based on the type of occupancy that it is. The final say is with the architect and authority having jurisdiction. The areas that are close to assembly occupancy should be questioned, should be aired to the caution side. So if a multi-purpose room and didn't have the requirements, if it was being used as a ballroom at times, but being used as other times, we would have to look at exactly what the maximum occupancy could be and multiply that out. So in general, anything over 50, the doors would need to swing out, and 50 or more people in each section would require an exit device. When you multiply that out into those multiple rooms, that would change things as well. Other red flags within other occupancies that could be assembly would be large classrooms. Large classrooms that hold 50 or more people. The egress calculator would guide you into using the more restrictive. And again, the final say is with the architect, but in those rooms that have the capacity of 50 or more people, even in classrooms, those egress doors should swing in the direction of egress. And sometimes the architect will have a problem with that, and we'll just need to show them in code where it tells them. Door hardware height. Door handles, push, pulls, latches, locks, and other operating hardware should be installed within 34 to 48 inches above finished floor. Auxiliary locks used for security purposes and not used for normal operation are permitted. Unless by exception, the unlatching of any door or leaf shall not require more than one operation. This is important to keep in mind when specifying hardware on pairs of doors where both leaves are required for exit purposes. Looking at the paired opening that we have in the picture here on the right, we are showing you both doors are active. Both doors have an exit device that does not require the other one in order to operate. You can go out either door. Exit devices are required in Group A, assembly, and Group E, educational occupancies with an occupant load of 50 or more people, or in Group H, high hazard, regardless of occupant load. They're required on doors from electrical rooms that have more than 1,200 amps of equipment in them. NFPA 101, the benchmark is 100 or more for assembly and educational. However, IBC is 50 or more. That's where the two codes are a little bit divergent. Panic hardware can have mechanical dogging and is listed in UL 305. However, fire exit hardware cannot have mechanical dogging. It will be listed in UL 305 and UL 10C. Panic hardware is rated for panic under UL, that's 305. Fire exit hardware is rated for panic as well as the fire rating. So UL 305 is the panic, UL 10C is the fire rating. And again, the actuating portion must extend half the width of a door. This is where it gets tricky sometimes with stocking distributors and wide doors. You must have an exit device that the actuating portion extends half the width of a door. And per the requirements, no more than 15 pounds to release the latch. So with less than 15 pounds of force, you have to be able to get out of that opening. Now, there are some more stringent requirements out there, specifically California, which we will talk about. California says 5 pounds of pressure to release the latch. So 5 pounds of force on that rail. We have addressed that situation. So again, for fire rated openings, there are some specifics that are different than your standard egress doors. Fire exit hardware has to be labeled for both fire and panic, as we discussed, shall have a permanently attached label that bears a serial number and shows the manufacturer's name and the type of approval. Their label shall differentiate between panic hardware, which is not acceptable on fire doors, and fire exit hardware. Conversely, NFPA 80 tells us that we cannot use fire-rated exit hardware on a non-fire rated opening. Talking about latch bolt throw. The throw of a single point latch bolt shall not be less than the minimum shown on the fire door label. The minimum throw shall be as specified in the manufacturer's installation instructions. The fire label will actually tell you whether that door needs a 1/2 inch or a 3/4 inch latch bolt throw. When you get into the higher fire ratings, paired openings, things like that, is where you will see that requirement for a 3/4 inch latch. All single doors and active leaves of pairs of doors shall be provided with an active latch bolt that cannot be held in retracted position, meaning you cannot dog it. Our panic exit devices either have a hex key dog or a cylindrical dogging. However, that will not work on a fire rated opening. If you need a way to electrically dog a device, electric latch retraction or electric dogging devices are available in fire-rated exit devices that will allow for the door latch to be held in retracted position until there's a loss of power from the system or the fire alarm goes off. That would then release and make that door self-latching, which is the requirement for fire rating. Okay. The throw of a single point latch bolt shall not be less than the minimum shown in the door label. We talked about that. Latches and strike plates need to be secured to the door and frame using manufacturer required fasteners. Pilot holes are required on wood and plastic covered composite doors. We talked about electric latch retraction and electric dogging is available of latches that can be held in a retracted position under normal condition, but will become latching at the time of fire because of a signal from the fire alarm or loss of power to the building. As we discussed, when both leaves are required for exit purposes, they shall be both provided with fire labeled exit hardware. Again, the method for calculating the egress width for the doors and how many doors you need exist in Chapter 10 of IBC. Once you determine that both leaves are required, you must provide the proper exit devices on both leaves of the opening. We also want to talk about accessibility. A lot of times these public buildings are required to also comply with ANSI A117, which is also ADA, Americans with Disabilities Act. ADA came into place in the early 1990s, and it is not a code. However, it is a law. It's civil rights legislation. And ANSI A117 ADA tells us that in a public building, you cannot purposely restrict someone from being able to enter your building. And if someone feels that you have denied them access because of a disability that they have, then it could be a reason to sue you. So most buildings now are designed with ADA in mind. Existing buildings are and have been upgraded over the years, but you'll still see from time to time there will be some special accommodations made for people that help those older buildings meet the ADA requirements. Let's talk about some of the ADA requirements. Chapter 4 is where most of our hardware discussions take place. Doorways shall have a clear opening of 32-inch minimum. Clear opening width of doorways with swinging doors will be measured from the face of the door across to the stop with the door open at 90 degrees. So with a 1.75-inch door hung on normal butt hinges or continuous hinges or offset pivots will give you 3 inches less than the nominal clear width. So a 36-inch wide door became the commercial standard because it gives you 33 inches clear. There'll be no projections on the door into the clear opening lower than 34 inches above floor. Projections into the clear opening between 34 inches and 80 inches shall not exceed 4 inches. So that 4-inch projection maximum allows for the exit device or the lock set or a piece of surface mounted hardware. It should all be very, very familiar because it's the same as what IBC requires for minimum clear width for doors and a means of egress. Handles, pulls, latches, locks, and other operable parts on accessible doors shall have a shape that is easy to grasp with one hand, does not require tight grasping, pinching, or twisting of the wrist to operate. Operable parts of the hardware shall be 34 to 48 inches above finished floor. Where there are sliding doors, when the sliding door is in the fully open position, the operating hardware shall be exposed and usable from both sides. Again, this matches what IBC tells us for hardware heights on doors in a means of egress. Operable parts of hardware shall be 34-inch minimum above the finished floor, 40 inches maximum above finished floor. Where sliding doors are in the fully open position, the operating hardware shall be exposed and usable from both sides. We just said that. There's an exception. Locks used for security purposes and not for normal operation shall not be required to comply with that section. So what they're talking about is an auxiliary deadbolt or something like that that's not used for normal operation can be mounted above that 48 inches. Door surfaces within the bottom 10 inches of the door shall be smooth on the push side, extending the full width of the door. Parts creating a horizontal or vertical joints in that surface shall be within a 1/16 of an inch on the same plane as the other. Cavities created by added kick plates shall be capped. So on the push side of that door, to meet ADA, you cannot have any latching hardware. So that's going to affect the selection of perhaps your exit device. So surface vertical rod type exit devices have a bottom latch. Per ADA, that is not possible. So what do we do in those situations? If we need surface vertical rod, we could do what they call less bottom rod. And that would allow for that bottom 10 inches of the door to be completely smooth. Now, a less bottom rod type exit device is a special product. You cannot just take a complete surface vertical rod exit device and omit the bottom latch. You will not be able to meet the fire rating requirements or your panic requirements. The latches for LBR or less bottom rod devices are specific. Door opening force. Per ADA, fire doors shall have the minimum opening force allowable by the appropriate authority having jurisdiction. Interior hinge door, 5-pound maximum. For sliding or folding doors, 5 pounds maximum. Those are for doors other than fire rated. So sometimes you'll see those two codes conflict. The more stringent must take precedence. In the case, this standard recognizes the importance of ensuring that fire doors are closed and latched at time of fire. And I don't want to say that it trumps ADA, but it kind of does. It is more important that that door is closed and latched than that 5-pound opening force. There are products out there that are designed to help meet ADA on a fire rated opening. So there are, different mountings for closers and different products available to help meet that. I had mentioned that 15 pounds of horizontal force on an exit device. California Building Code tells us the operable parts shall be operable with one hand and not require tight grasping, pinching, or twisting of the wrist. The force required to activate operable parts shall be 5 pounds. So that meant that we had to go back to the drawing board with our exit devices. And instead of meeting that original 15-pound requirement, we need a device that will operate under 5 pounds force. Sargent came out with a version on their rim and narrow style rim type devices. That is a 5CH option. That is a prefix to their device that will allow for that 5 pounds opening force. On their concealed vertical rod, it is also 5CH. Corbin Russwin, for their rim type exit devices, they have also come up with a 5 pound, and they use the same code. Theirs is actually at the end of their ordering string as a suffix instead of a prefix. That is a 5CH. So if you see them listed as 5CHs, that is the 5 pound force requirement. Yale on their 7000 series, their 71 and their 7150, theirs is called 5CA, and that is a prefix to their device. So know that all of our devices can be supplied in the most common configurations to meet that California code. And as things happen is if it's a good code, it will find its way out of California and around the rest of the country. So all manufacturers will be required to address that and create products that meet that code if they want to sell the product. So ASSA ABLOY has a unique product that we developed, and it is an egress calculator. So if you're working on a project and you need to know the occupant load of that space, the egress widths, how many exits you need, the swing directions of the doors, all of that can be done on our egress calculator through ASSA ABLOY. It's egresscalc.assaabloy.com. You can sign in through Connect if you're a distributor, or use our guest login. And by using this, it will allow you to determine exactly what you need. It's based around IBC requirements, and you can download that information. So if you happen to be a architectural rep working with an architect and you want to be able to give them the documentation, you can print it right off of here. So it is a really nice tool. And we actually do a virtual class several times a month that can teach you how to use this and how to make it work for you. At this point, I will open it up for any questions. If you do have any questions regarding codes, you can reach out to Katie Flower. She is our Academy codes expert, Catherine.flower@assaabloy.com. Mine is Thomas.Seidel@assaabloy.com. If we don't have any questions, I will go ahead and thank you for attending and hope to see you soon. Thanks, everyone.